Today we're going to be talking about acids, bases, and pH. We're going to start by looking at pH. pH is a scale we use to measure how acidic or how basic something is. It's sometimes referred to as the power or potential hydrogen or hydronium. To understand what this means, the power of hydrogen or the potential of hydrogen or hydronium, we need to start by looking at water. When we look at a water molecule, H2O, we know that's made up of one oxygen atom and two hydrogen atoms that are bonded covalently. So remember from chemistry, we learned that a covalent bond is one where they share electrons. So in water, we have two hydrogen and one oxygen sharing electrons. The problem is that in water, this isn't an equal sharing of electrons. In fact, the oxygen pulls some more of the electrons towards it. This creates what's called a polar covalent bond, where the electrons are shared unequally. The oxygen, as I said, pulls more of the electrons towards it, so it creates a pole that is more negative, whereas the hydrogen end of the molecule ends up being more positive. This is called a polar molecule. What happens is when we have more than one polar molecule, like in the case of water where we have lots of molecules of water, the positive end of one water molecule will become attracted to the negative end of another water molecule. And this creates a special kind of bond from the attraction between the positive and negative charges. This is called a hydrogen bond. And these hydrogen bonds give water all kinds of cool properties that we don't talk about this year, properties like cohesion. Sometimes, though, the hydrogen is actually pulled so hard that it leaves one water molecule and joins another. So this is a picture that shows how that hydrogen ion, the proton, is detached from one water molecule and attaches to another. This leaves one water molecule that has lost a hydrogen and now becomes a hydroxide ion, OH-, and one that has gained an extra hydrogen ion and has become hydronium, or H3O+. And sometimes, very small amount, these water molecules will do this, but this also goes the other way. The hydronium and the hydroxide can recombine to create two water molecules. And this is always happening in balance, going from two water to hydronium and hydroxide back to two water. Sometimes at a grade 9 level, this is a little bit too complex. So we try and make it simpler by thinking about water as breaking apart into hydroxide ion and a hydrogen ion. So you can see in this picture, that would be if we just lost one hydrogen and we're left with an OH- and an H+. This is why pH is sometimes referred to as having a hydrogen and sometimes referred to as hydronium. And certain textbooks or worksheets, or even myself, I'll go between calling it those two different things. So going back to pH now, we can see that pH measures how much hydronium or hydrogen ions there are. It involves some pretty complex math that we're not going to go into right now, but if you're interested in that type of math, we can talk about it later. The way the scale is set up is that water, which has a balance of hydroxide and hydronium, is in the middle of the scale. It's considered neutral, and it's assigned a pH of 7. Again, this is due to some math that we're not going to talk about in grade 9. The scale goes in both directions, going from sometimes it's listed as 0 to 14 or 1 to 13. When we look at the left-hand side, or the numbers less than 7, that is considered acidic. And we know that an acid is something that is going to start with an H, a hydrogen. In this case, we're going to look at hydrochloric acid, which has the formula HCl. When an acid is added to water, because it is an ionic compound, it's going to dissociate, or it's going to break down into water into its ions. In this case, it's going to break down into H+ and Cl-. When it does this, it adds hydrogen to the solution. So a pH that is less than 7 actually has an increase in the amount of hydrogen. It seems a little backwards, but you'll get used to it. So the acidic side is anything less than 7, and it actually has an increase in the hydrogen because of the dissociation of that ionic compound. So just to look at some of the properties then of acids, acids always have a formula that starts with H. They always have a pH that is lower than 7. They produce hydrogen or hydroxide ions in the solution, and they taste sour. Citrus juices like lemon, orange, grapefruit are all acids, and they have that classic sour taste. Vinegar, coffee, soda water are also all acidic, but as the pH gets lower, acids become stronger and it can be dangerous. So we'd never taste anything in the chemistry lab to determine whether or not it was an acid. Strong acids can be very dangerous and they can cause damage to our cells and tissue damage, so we want to be careful not to touch or taste anything in the chemistry lab, just like our safety rules have always been. So what happens if we look at the other side of the pH scale? So in the middle, we have the neutral, which is water. Then to the left, going less than 7 is acidic. That means that greater than 7 is basic. So we're going to talk about an example of a base. In this case, we're going to talk about sodium hydroxide. So sodium hydroxide is also known as lye. It is a compound that is used in lots of cleaning products and soap. Sometimes basic compounds are also referred to as being alkaline. It's just another word that we use sometimes to describe bases. Just like the acids do, because our base in this case is also an ionic compound, it's going to break apart or dissociate into pieces. In this case, we have the sodium, Na+ ion, and our hydroxide ion, OH-. Now, this isn't actually adding any hydrogen to a solution, but what happens is because we already have this in water, there are already hydrogen ions that are floating around. When those hydrogen ions come close to the hydroxide ions, they're going to be attracted because of the positive and negative charge, and they're going to form water. So essentially, a base actually pulls hydrogen out of a solution and lowers the concentration of hydrogen because it's going to react those hydrogen ions with the hydroxide ions that are coming from the basic solution. What do we know about bases then? We know that the formula always ends in an OH to be producing those hydroxide ions. We know that they have a pH of greater than 7. And that they produce hydroxide ions, OH- ions, and that in turn those hydroxide ions actually reduce the concentration of hydrogen ions by turning them into water. When we talk about the taste, they tend to have a bitter taste and they would feel slippery to the touch. Bases include things like soaps and cleaning products, even things like oven cleaner and bleach. It's very important, again, that we're never tasting or touching anything in chemistry unless you've been specifically told to do so. Just like strong acids, strong bases can be very dangerous and can cause damage to our cells. It wouldn't make sense to have to taste something to decide if it was an acid or a base, which is why we use the pH scale to measure how acidic or basic a substance is.